Next presentation is Energy Efficiency and Funding Opportunities, and is presented by Jen Muir, President of J.K. Muir Associates. I don't know if it's Associates or not, is it? Jen is President of J.K. Muir, an environmental consultant firm specializing in engineering and energy projects and wastewater facilities. Jen's experience includes conducting energy evaluations of wastewater treatment facilities, calculation of energy and cost savings, design of improvements, and obtaining grant funding through the electrical utilities. Jen received her bachelor's and master's degree from MIT in environmental engineering. She is a professional engineer, and J.K. Muir is registered as a WBE in Connecticut, Massachusetts, Rhode Island, and New York. Jen currently serves on the board of Connecticut's section of AWWA and is a member of NUIA's Energy Committee. So I'd like to welcome Jen. There she is.
Good afternoon. So me and pump efficiency now stand between you and your much-deserved lunch. So let's go on this little adventure together here. So there's three questions that kind of come up and may come to your mind when we start to talk about energy efficiency opportunities or energy projects. Why do we care? And I don't mean to be flippant about this, but I think it's a realistic question. I was in a meeting this week and someone said, haven't we done enough? You know, we've invested a lot in energy efficiency. Isn't that enough? And so I want to address that a little bit. Of course, what can we do about it? How do we identify energy opportunities and how are we going to implement them? And not the least of which, and probably the most important, of course, is who's going to pay for it. So I think we hear a lot about the triple bottom line and sustainability. So what does that mean? Well, basically it addresses the fact that we are environmental stewards, but also because we are public entities, we're serving the public, there's also an economic and social element to what we're doing. Along those lines, I think greenhouse gases has become somewhat of a buzzword, but I do want to mention some of the 80 by 50 initiatives that are taking place regionally, internationally, domestically here in the US. If you're not familiar with what the 80 by 50 means, it basically means that mayors, state and city mayors internationally and here in the US have committed to reducing greenhouse gases by 80% by the year 2050. And in fact, what you may not know is that not only large cities like the city of New York have committed to this, but also there is a Connecticut state initiative, 80 by 50 initiative. So I think what's most significant about this is this really goes beyond saying we're going to promote solar, residential solar in our state, or we're going to really assist technology companies coming in and working on smart grid, or we're going to create incentives for industrial efficiency. This is really making a commitment and a very substantial one, and it's a quantifiable commitment. So not to mention, it's pretty drastic. How are we going to get there? We're not going to get to 80% by changing light bulbs and getting new air conditioners. So that's what I wanted to mention about it. In fact, our program here in Connecticut, it's been said that there's going to be significant additional measures and breakthrough technologies required in order to meet this. What New York City said about their 80 by 50 plan is that, again, getting back to this triple bottom line concept, is that while it's a greenhouse gas reduction initiative, it is intended to promote economic prosperity, social equity, enhance quality of life, and of course, climate resilience. As some of you may be familiar, we're getting this phrase of net zero wastewater treatment facilities, net zero energy facilities, and we've seen WRF and NYSERDA put out this guide to net zero recently. I think it was put out last year. And so there's certainly a movement towards this. So my message here is really that I don't think we've heard the last of this, and that we are going to be expected to be increasingly accountable and asked to do more. In fact, when I was meeting with the New York City DEP this week, the Mayor's Office of Sustainability in New York City looked at them and said, DEP Operations Bureau, what are you going to do about the greenhouse gases associated with your biosolids disposal? So you can imagine how that meeting went. But that's the expectation that's being placed on our industry. So when I think about energy opportunities, I really see them in three buckets. There's the idea of our usage reduction, energy efficiency, and more importantly, how can we benchmark it? How can we use less energy to treat the same amount of water? And then, of course, on-site generation. And this has to do with both resiliency and moving towards a net zero type of facility. How can we produce more power on site? How can we do it renewably? And then of course, energy management. Do we understand how to control our costs? Do we understand how we're being billed and how we can control it? So just talking about that first aspect of efficiency. So I like this quote because I really think it says a lot. It says, if we want to avoid extreme efficiency, we want to avoid extreme energy, we need extreme efficiency. So what's extreme energy? Well, it's really the fracking, the deep ocean drilling, and the environmental side effects that we see. We see it in the news all the time. So if we want to avoid that, what do we need to do? Extreme efficiency. Well, what's that? Well, it's really a deeper dive into efficiency. And I think that's really where some of our efficiency measures and efforts come into play. I think you all are very familiar probably with what some of the energy efficiency opportunities are at wastewater facilities. Of course, they're all around us with regards to pumping, aeration, mixing, solids handling, as well as any kind of process optimization. But one of the things that's come out of some of the 80 by 50 initiatives is that they're really realizing the tremendous amount of energy that buildings use. And we certainly have a lot of buildings in our industry, and we tend to ventilate them very, very well because of our NFPA 820 regulations. And so I don't want to undermine or dismiss the fact that we have a lot of heating, ventilating, building system opportunities. I really like this graph actually because sometimes we show up to do the site visits and we've got our flow meters and pressure gauges and electrical metering equipment. But when we look at the energy profile, particularly of, let's say, a small pump station, we often see very high energy usage in the winter, really dips down during the summer months, and then high in the winter again. So while we like to talk about pumps and big equipment because that's really fun, often it is really the building systems that hold some substantial opportunity. So one of the most important and powerful things you can do is benchmark a facility against other facilities. We of course recognize that there's some economy of scale. Facilities that treat more flow are going to be able to do so at a lower energy intensity per million gallons treated. But it's a great way to see, does a facility fall in line? Is it an outlier? How much opportunity might we see? One of the other really useful tools that can be done relatively simply is just take a look at all the equipment in any building or facility, look at everything, let's say 1 horsepower and higher, how many hours does it operate, and create essentially an energy balance. Now we can kind of look at this and have our eye on where is the most power being used, where can we get the most bang for our buck. So of course we see a lot of energy usage in aeration and pumping systems. Sometimes we're often surprised how much systems like plant water or solids handling can really impact the total bottom line of energy usage. So I know that you all read the WE&T magazine cover to cover every month, and so you probably recognize this cover from a few months ago. But I really love it because it says the art of transporting wastewater. And if anyone in the crowd is looking for a last minute Mother's Day gift for me, I think this would look sweet. Poster size in my office. But I like this because it's a perfect transition to the next part of my presentation. And what's fascinating to me about this is I looked at it for a long time because I thought it was a quite artistic demonstration. But there's no pump in the picture. And so what's interesting to me about it is that when we actually look at the energy usage of pumping systems, the most important part of the equation is flow times head. Flow times head equals the amount of energy a pump is going to use. So really my point here is that it has very little to do with the pump. It's really everything about the condition that it's pumping in. How much flow, how high are you lifting it, what kind of pipe, what kind of material is it? So towards that end, I like to talk about pump efficiency because it's something that we spend a lot of time on. It's really one of the most, we're never going to get rid of pumping. We're always going to have to move the water around. So something that it's a very useful aspect in terms of looking at energy efficiency. So what are the type of efficiency opportunities? Again, maybe it's not about the pumps, it's about the valves and the piping. The pumps are also subject to the material that they're pumping. We know that they're subject to an extensive amount of wear, seals, clearances, vibration. This can all impact their efficiency. Impellers get modified, again, efficiency modifications. Now, just like we've been hearing about today, we need to design everything for those wettest, highest flow days, what I like to call the apocalypse. And so on nice, happy, dry days, our pumps are really turned relatively down. And that's when we tend to see things like cavitation, and this all has an impact on how efficiently that pump can operate. So one of the best ways to get your hands on how well a pump is operating is to do pump efficiency testing. And really what this means is taking field readings. So again, we're not looking at the pump curve, we're not going necessarily looking at the manufacturer's data, real live field testing, flow monitoring, pressure instrumentation, and of course, a look at the electrical energy usage. So getting that spot reading, and then you're able to compare that to the original pump performance. And is there an opportunity there, and what's the savings associated with it? So if any of you work with millennials, you know that you have to do everything with an app. And if you can't do it on your phone, it's not worth doing. So that's why we actually are able to do the pump efficiency data collection using an app. But I want to just go through some of the screens to give you a sense of how simply you can get at a quick reading on the efficiency, the actual operating efficiency of a pump. So of course, by entering some motor data, the speed, the horsepower, and of course, the efficiency of the motor itself. One of the things that, of course, we know is that motor efficiency is now improved. Almost all the motors that we come across are NEMA premium efficiency motors. And I would be remiss not to mention that we see that the DOE has promulgated new ruling associated with pump efficiency. So just like we saw this requirement that motors sold in the US are going to have to meet a certain efficiency standard, that is also going to be now pushed down to the pump manufacturers as well. So we should in the coming years see some higher efficiency pumps become available to us and actually required. So again, we enter some of our field data, pressure, flow, like I was mentioning, and of course the electrical usage. You'll note that we also take a look at the power factor, and probably a talk for another day is about reading electric bills, how we get charged for things like demand, and power factor can certainly be an element of that. So in doing some of the field data collection, you can really get your hands on where something like a low power factor might be coming into play. And of course, it spits out your pump efficiency. Okay, great, so what do we do with it? So bear with me here at the end of the session while we take a quick look at a pump curve. But really what this is showing you is that the flow versus head pump curve, and we overlay the system curve on it. We can look at variable speed analysis of the pump, so how it operates at different speeds. And one of the things I want to point out about this is that as you turn a pump down, you can see what we've demonstrated here is actually a relatively flat system curve. The thing I want to point out is that this pump is designed for about an 82–83% efficiency. That's the number that we see over here closer to its design point. As you turn that pump down, you're actually moving across quite a few of these ISO efficiency lines. And this is why we don't always see the savings associated with VFDs that we expect to. It's all about the system curve. So again, it's not the pump's fault. It's not about the pump. It has to do with that system curve. For the engineers in the room, one of the things that's really fun about this is that we often are replacing pumps in existing plants. We're using existing piping. By doing this kind of testing, we're recreating or we're creating the actual system curve. So instead of using a modeling technique, we can get that actual real data on the system curve. You know, for fun if you're into that. So if you had an energy evaluation done, I see a lot of familiar faces in the room of people who have, then you probably have one of these lists of your possible energy conservation measures. And one of the things I just wanted to point out quickly is that the rebuild or pump replacement options that are associated with improving pump efficiency often tend to be pretty high yield in terms of their ability to give you some good savings, and they're also usually relatively short payback type of projects as well. I think if you've read some of the industry magazines or seen some presentations, we do hear people talking about pump coatings. And really it's the idea of if we coat the interior of the pump, can it increase its efficiency? And more importantly, can it prolong the life of that efficiency rating? So it's going to maintain that efficiency for a longer period of time. So most of the time, kind of on average, when we look at pump efficiency, we see that most pumps are operating in that 20–30% their rated efficiency. So there's a cost associated with that, and often a pretty good return on investment in improving it. So one of the things that's interesting is when you're out in the plants, you often will hear folks say, hey, you know what, our guy down the street who does our pump rebuilds, I think they throw a coating on it for us. But we don't really have the empirical data. So one of the things that National Grid is doing is actually trying to get their hands on some of the data. So we're actually doing some of the pre and post testing on that coating. So it'll be interesting to see the results of that. So again, in that second bucket, I talked about on-site generation. And I think we also have this concept of like, are renewables for real? Like, how much are we really moving in this direction? Do I really have to do this at my facility? You know, the mayor said I have to have a fuel cell. You know, what does this really mean for me? And so just a quick glimpse is that globally we see that 26% of the energy supply currently comes from renewables. The new capacity being added, we're seeing renewables is probably about 50%, and we anticipate that to continue to grow. What this means is that the technology is getting cheaper. It's changing very rapidly. Things you might have heard about renewables technology, on-site generation options, are different than what you may have heard a few years ago. So I think there's some really traditional things that we think about when we think about renewables. We think about solar panels. Of course, here in Connecticut, we always think about fuel cells, of course, and maybe some mini hydro. There's some facilities that have experimented with that. I want to throw a couple examples up of just to give you a glimpse of what's happening potentially internationally and domestically here in the US with regards to mining the energy that's available at wastewater facilities. I like this example from Vancouver. Basically what they've just said is we want all our buildings to be energy neutral by 2020. And one of the ways that they've done this is to set up a facility which will mine the heat from raw sewage and utilize that in sort of a district heating type of scenario, and then it distributes it to the local residential and commercial buildings. So kind of a cool example. They've also said that now you don't have to have HVAC on top of your building roof, so now you have more room for green roofs. So that's one of their other selling points on this project. So if you're familiar with Philadelphia and some of the things that they're kind of doing a multiple prong approach. While they're doing a lot of energy efficiency, they want to see themselves move towards a net zero facility. And one of the ways that they're doing that is, again, looking at mining the heat from the sewage, so utilizing that heating load. They actually take aircraft de-icer from the airport to increase their methane production, and they've got solar panels, and again, the biosolids come up. So knowing that the impact of the greenhouse gas impact of biosolids disposal, I heard someone earlier mention about the transportation and greenhouse gases associated with that. So they're looking towards beneficial reuse types of options as well. One of the most interesting things to me that I think we're going to see a little bit of a change in our industry is that I know we're kind of an exclusive industry. You know, we kind of hang out with each other. I bet a lot of you here know at least half the people in the room. And one of the things that we see happening is there's a lot of regulation going on with solids, on the solids waste stream, and organics recycling. So it's interesting to me because we don't really hang out with the garbage people, and maybe they don't want to hang out with us, but nonetheless, I think we're going to be joining forces here in a number of areas. This is just a quick graph. It shows the volume of food scraps that are disposed of in Connecticut, the permitted capacity of facilities that are available to take those food scraps, and then what's currently recycled. So as you probably know, there is some rules that have been promulgated that address food waste and food scraps. That basically says if you're a reasonable sized producer of food waste or of source separated organics, as we call it, then you're going to be, and you're located close enough to a facility that will take it, you're being asked or you're being mandated to make sure those materials are recycled. So one of the most natural ways to recycle organics is, of course, to anaerobically digest them. What better way to anaerobically digest them is if you have a facility that already has digesters like a wastewater treatment plant. So we might be spending more time with the solid waste folks. So who's doing this? We see Oakland, California should be probably one of the first North American wastewater treatment facilities that's going to be a net energy producer. And again, it has a lot to do with the fact that they're going to take in food waste and digest it and create a lot of biogas. So they're going to export that out to the grid. We see this happening more locally. You may have seen in the news, of course, at Newtown Creek and the famous egg-shaped digesters, they're also doing a food waste pilot. And what's interesting about this is, along with taking New York City's food waste, which New York City has committed to zero waste to landfills by 2030. So this is part of the support of that initiative. So kind of like it or not, it's moving into the wastewater industry. And what's interesting about this is they're actually going to purify the gas and send it directly into the natural gas distribution grid to be used homes and businesses. Of course, more locally, we have the Bridgeport project, and this is also going to be anaerobic digestion, which is going to take both the Bridgeport wastewater treatment facilities sewage sludge as well as organics. So producing a class 1 renewable. And this is part of the city's Be Green initiative, taking in private industry, so utilizing a design, build, operate type of project. So of course, the best way to provide funding for our energy projects is through the Energize CT program. There are a number of people here who represent UI and Eversource, who are the administrators of this program. And if you guys could just quickly raise your hand or stand up. Great, thank you. So I want to point out that they're here, and it's not because they heard the food was good or because they like our jokes. It's really because they have strong initiatives to work with our industry. They really want to partner with us, get involved in the projects early, and there's lots of funding available. In fact, there's more than one wastewater utility represented here in this room that's gotten over $1 million through this program. So they have a dedicated effort. They've worked closely with EPA to really try and reach out and be part of our projects. So I always like to mention that the Energize CT programs and basically the energy incentives that are available, these are ratepayer funded programs, meaning it's a little charge on your bill, so we're all paying into it. So what better reason to go forward with trying to get some of your money back, as well as get some of your projects funded. So again, up to 75% of the project can be covered. There is funding available. I'm also going to touch briefly on the LREC and ZREC program. And I want to mention someone else had talked briefly about the opportunity for performance contracting. And the Connecticut Green Bank has worked really hard to make performance contracting a very viable option in our state so that we can have outside or private funding, which reduces the capital costs on our utilities. So it's also a really good option. So the LREC-ZREC program is really the way to go if you want to do a renewable project. And what's really nice about this is it's a 15-year commitment. If you enter into this contract, you're guaranteed that REC price for 15 years. So it's really a great funding mechanism. It's a 6-year program. We're about halfway through it, and there's $1 billion in committed funds to this. So many of you may have already had a good experience utilizing this. But this is really our go-to program with regards to renewables. The Connecticut Deep folks are here, of course, and mention some of their reserve funding, but I like to also mention this in the context of energy projects. So the Green Infrastructure Reserve that was mentioned, it specifically says cost-effective renewable energy components at treatment plants. So certainly we could find some viable projects for that. The Pump Station Reserve also includes a specific reference to energy efficiency, pump station improvement projects that result in a reduction in energy consumption, increase in resiliency, or an upgrade to ability to provide emergency power. So these are also good funding sources that you can leverage. They're not mutually exclusive, meaning that you can utilize Eversource UI funding in addition to using Connecticut Deep funding as well. I want to just mention briefly the best way to maximize the funding that you're getting through these programs, and that really has to do with an energy conscious design. And this really just means getting these elements into the design as you're working on it, so not during construction, of course. And this can just be as simply as knowing that the LED lighting fixtures need to be on the Design Lights Consortium list, or making sure that the HVAC equipment is spec'd to meet the Eversource efficiency standards. And really what all this means is just ensures that you're going to get that incentive money. Nothing is going to function as efficiently as designed if it's not commissioned well. So we like to see a healthy commissioning program that includes testing, really requiring some of those set points in programming to be as intended. And really this, again, starts with design. How can we require the manufacturers and suppliers to meet these efficiency requirements, and by really putting that into the design documents. Nothing beats a good energy management program, and this really has to do with who's tracking the bills, who's in charge of looking at them, how can we find discrepancies, how do we benchmark our own performance. And this also includes understanding how you're being billed for demand and how that impacts your bottom line. Many of the facilities represented here are one-shift facilities. What does that mean? 6, 7 in the morning, we come in, turn everything on, and that's where we get to see a lot of the peak demand, which can impact our bottom line. The last thing I want to mention is that we see statewide and nationally a lot of our wastewater entities and utilities are entering into substantial asset management programs. How can we combine this with the energy efficiency effort? How can we utilize some of the field data I was talking about earlier to get to root failure analysis? How do we incorporate the payback associated with an energy project into prioritizing asset management type of projects? And with that, happy to take questions.
Anyone have questions for Jen? Gotta be questions.
Well, now you mentioned hydro because obviously we're running water over weirs and through pipes all the time. I know in Europe the wave technology, where you're using tidal forces, I wonder if you read any literature that could be applicable to through pipes, harnessing that thermo, that hydropower to a pipe over a weir, what's on the horizon possibly.
Yeah, so actually it's a great point, and often we look for the best applications where, let's say we have some head at the effluent, and it's a really simple equation to figure out how much energy you could produce by just looking at the flow in that, let's say your discharge pipeline and the head that might be available. And there are a number of technologies, both in pipe or open channel, that are being experimented with that can harness some of the, I kind of call it mini hydro, that we have available at the treatment plants. So certainly one of the technologies that's out there and been experimented a little bit within the state, actually.
Thank you very much, Jen.